Oh, hello! I'm just popping by with some of the most recent exciting cosmological news. LIGO, already a scientific superstar for being the first facility to successfully detect gravitational waves, is getting a quantum upgrade. That's right, the facility that is already considered one of the most advanced pieces of equipment on the planet is getting a roughly $35 million facelift. Projected to go into use around 2024, the enhancements to LIGO could double its already impressive detection power. We went into a little more detail about how LIGO works in another video of mine that we'll link at the end of this video, but basically, there are two LIGO facilities in two different states in the US. Each facility has two 4-kilometer-long arms, down which scientists bounce a laser toward a mirror at the other end. Then, when the light bounces back and the beams cross one another, the light waves should cancel each other out. But if there's an extremely subtle shift in the universe, and we are talking extremely subtle, like a gravitational wave, the two light waves won't cancel each other out. The mirrors will have shifted just enough that the light waves are out of sync in a way that we can measure. Based on the results that are recorded by the detector, scientists can then interpret the data to see if the facility has detected a gravitational wave, a ripple in space-time caused by a huge astrophysical event, like the collision of cosmological objects like neutron stars or black holes. Obviously, a problem here is making sure the readings you're detecting are really gravitational waves, not just some other disturbance like the natural vibration of the Earth. And while LIGO already has lots of successful measures in place to prevent the measurements from being interfered with by things that are not gravitational waves, it could always get better. Additionally, some of the LIGO improvements are an effort to address the Heisenberg uncertainty principle, or the idea that it's impossible to exactly measure more than one aspect of a phenomenon at a time. For example, any attempt to precisely measure the velocity of an electron will, according to Heisenberg, disrupt its trajectory. You couldn't also measure the electron's position and have it be unaffected by your measurement of the velocity. Basically, you can't measure two things at once and have them both be accurate. The principle, in principle, applies to everything from your car to your molecules, but it's only really significant for things on microscopic or, more often, subatomic scales. This is relevant because the light beams that LIGO's calculations rely on have two different important aspects that both need to be measured in order to get a good reading. Its phase, which is the light's position at any given point in time, and its amplitude, which can be defined as the light's intensity. And because we're trying to measure more than one aspect of these light beams, the Heisenberg uncertainty principle can cause some additional murkiness around detections, making it even more difficult to pick out gravitational waves from other non-gravitational wave noise. To solve this problem, in the upgraded facility, LIGO will start using quantum squeezed light. This frequency-dependent squeezing technique will hopefully minimize fluctuations in the light's phase, making the measurements of the light's amplitude more accurate, minimizing the effect of the Heisenberg uncertainty principle. The upgrade also includes new mirrors with advanced coatings specially designed to even further reduce any extra noise caused by heat. These improvements are what will take this history-making facility from LIGO to ALIGO Plus, the Advanced Laser Interferometer Gravitational Wave Observatory Plus. The changes not only mean that scientists could catch a gravitational wave every day, but could also be able to detect smaller events happening farther away in space, and know way more about what the events were like. Were the black holes spinning when they crashed into each other? Burning questions we may soon actually get to know the answer to. Ultimately, this means more concrete evidence in our search to uncover the mysteries of extreme physics in space, which gives us more insight into the universe both as it is now and as it came to be. Like we mentioned before, check out this video here on some drama about LIGO's measuring techniques, and make sure you come back to Seeger for all your gravitational wave updates, like the LIGO facility in India that's slated for 2025. As always, thanks for watching, and we'll see you in the next one.